Alright, recording started. Alright guys, thank you. We're gonna have Harpreet and Sai present.
So this is our problem. It's called Mercari Price Suggestion Challenge. So Mercari is a Japanese brand in which you can sell second-hand stuff. Maybe it's a T-shirt, maybe it's an PS3, maybe. So can you go to the website? I'll just show you guys the website.
Second-hand stuff.
Yeah. So like you can see here, you can their prices worth $8. Then there's something. Can you go up a bit? Yeah. So there's something which is $4. I think it's some $9 or something. So I think there'll be another page open. Can you click? There's another page open. Another of that page. So yeah. So this is click an item. Suppose we have OLX right in India. So suppose you want to sell something, maybe say your iPhone, your old iPhone. So you can just write down. You don't know what price should you sell it for. Maybe $10,000, maybe $15,000. You don't know the exact price. So if you go down, okay. So here you can put a description. What kind of iPhone is it? They say it's a 5S, it's unlocked, and it has outer box case, which should be outer box, but it's the product, the spelling is wrong. So basically, this is the format in which you put your stuff and you publicize it that I want to sell this. So this was our problem. So since you don't know what price you should put, our main challenge was to predict the price. What should be that price. So then again we were having a problem, and the problem was, suppose you have two sweaters and you have to think which one costs like how much. So one can cost $9, other one can cost $300. That's more than 16,000 rupees. So how do you guys just look at it and think that does this thing should belong in a 400 rupees categories or $9 here, or let's say a $16,000 category. So this was our problem. Next. So this was a statement problem. We did this problem on Kaggle. So Kaggle is a platform on which you have all the data science contests. So if you're interested in data science, Kaggle is the platform where they put down their data set. So data set is basically people like us who have put on their prices, and looking at those prices, we understand and we train our model. We tell our model that this is the history, this is how the data looked. Can you predict this new item, how much will it cost? And these were our factors which were given to us. There was some ID associated with it, a name, item, condition. Is it a good item? As many people say, if you have been to OLX, they say it's in a mint condition or fresh condition, right? So you can put down item condition. Then the category name. Category name had 3 subcategories inside it, which we'll go through. A brand name, does it belong to Apple, does it belong to Samsung, or it's Xiaomi? So it can be a good factor in deciding what the price of item should be. Then there is a price of the item it's sold for. This is for training our model, but in the end we have to predict it. So in our test set there will be no price. Then there was shipping. Shipping means, does the seller who's selling it, does he provide the shipping? Sometimes in Amazon, if you have tried buying something, they ask you 50 rupees, for the item extra on selling or shipping charges. And the last is the item description, like we saw that the iPhone 5S with an outer box and stuff. So that's come under item description. Next. So now Zaf will tell you how we were trying to understand the data. So we plotted some graphs and what those graphs tell us.
So we plotted a count plot on item condition where we have 5 unique IDs with one being having the highest frequency and 5 being the least one. So next plot we have the box plot. You can observe that from the item condition 1 to 4 the price is a bit lower, and for item condition 5 the price is high. This is because the frequency in the first plot is less. So the price of the product is high. So this is the distribution of price by shipping. So one being the free shipping, that means the price is paid by the seller, and zero is the price paid by the buyer. So you can observe that for one free shipping there is a decrease in price. That means the price is less for free shipping. And here are the top 25 most expensive brands. So Air Jordan is the shoe brand which has the $80, which is the most expensive brand, and the least expensive is Wet n Wild. And we plotted this graph explaining the brands and their prices. So this is the item category. So before splitting the item category, we plotted the median with item category, and in the similar way the median price is less for sports and other products, and high for vintage and collection antique furniture. So can say that the furniture prices are most expensive in the item category. So here are many outliers for median log prices of the brand categories. So these are the top 10 brands of the categories. So those are the brands, and these are the first category. We split the category into three categories. So this is the first category and the brands. So Pink has the most sold brands for the first category, that is women and other men categories are sold by the Pink, and Nike brand sells men products and sports and outdoor products and other men products.
So most of the products are for women,
Yeah.
like category,
Like they want there's makeup and there's shoes for women.
and those are the most dominant type of category.
So these are the categories which we split into three. So here we have listed two categories. Okay.
So guys, as we saw that how they had first categories for items, maybe the mobile phone, so it comes under electronic category. So just by reading the categories, our model can understand a bit. A model can think that maybe laptop prices are supposed to be high, so it tries to understand that from the given data. And now coming to the text data. Text was the description as I showed you. So people might write anything in a test description, right? The best phone ever, never used it, mint condition. So how do we extract the important data out of it? If we tell a computer, if we tell a algorithm, that this is the best phone and never used it, it's the brand new phone. So a computer does not understand words. We have to associate those words with numbers in order to explain the computer that these words mean something in mathematics which it can understand in zeros and ones. So as we there are some functions which we can use for that, and then after using those functions, I'll explain. If you want to know about the algorithms we use in it, I'll explain how the algorithms works. So now I'll just tell you how these words work. So if you see the most common, these are the frequencies and these are the words. So the top 25 most common description words. New is the unfirst. Any guesses why new is on the top?
New phone, they put up insert in the description.
Yeah. Sometimes people buy stuff and they don't like it afterwards, right? So they want to sell it back and they are like, it's brand new. The second one is the size, the ship, and the brand, and it's free, something is free, or the cable is free with it. So these were the top 25 descriptions. And I used there's this function which I can use, it's called the cloud words. So you can see it defines that the biggest words have the most frequency, and if you see the small one, the wants, the purchase, look, top, fit. So these are the lists. Next. So as you see, people might write a paragraph on it or 10 lines on it. Who knows? So I plotted a graph in order to see, what is the correlation if a person is writing maybe a paragraph for the same stuff which other guy is selling for 5 words, new iPhone, packed. So if you see the length of characters when plotted against mean log price. So price, now I'm using log price because the data science guys will learn about this, that these models, they need a Gaussian distribution. So Gaussian distribution is something like this. So that means, the maximum amount of frequency that lies in the center. I'll explain this if you guys are interested.
Yes.
You are? Oh, cool. So suppose, let's say you have a dice, and what is the probability of getting, let's say, a number 3 in a dice?
1 by 3. 1 by 3.
1
1 by 6. 1 by 6.
1 by 6 is a good answer. So if I do it for 6 times, you won't obviously have all the 6 numbers, right? So let's do this for 1,000,000 times, So do you think we'll have an equal division of 1 by 6 in this? Like all the numbers will occur 1 by 6? No, right? So what happens is sometimes, there's some number, let's say 3 for convenience. So 3 will have the highest probability in it. So out of 1 lakh or 100,000, so let's say this represents 40,000. So 3 has 40,000 and 2, 1 and 4 and 5. So you guys understand this, right? That how these probabilities...
According to this, 3 is the most likely.
Yeah, as I said, let's imagine, just for the convenience of understanding, that 3 was the most likely, that it occurred 40,000 times when we rolled a dice 1 lakh times. Do you guys understand? So this is the Gaussian distribution, this bell-shaped curve. This is important for machine learning. So when we have a Gaussian distribution, our machine learning works perfectly fine. So I use the log price along with the length of characters, and when I plot it, what I see is people have gone to the length of writing 1,000 words for a description, and the prices, they change like this. So if you see, the maximum price was attained around, let's say 400 words, when the price was above 3 or log of 3. You just have to e to the power, you have to do that in order to find the price. Next. So there's something called n-gram. So I used 3 gram. So basically, an n-gram, as I showed you the figure in which new was on the top, right? So 3 gram represents which 3 words are used most frequently together. Which 3 words? So if you see, the price is firm. So a person who does not want to negotiate is like, price is firm. So these were the top 25 new with tags, brand new, never used, I think. Yeah, next. And the algorithm we used in these were random forest regression, because it was giving us the best, least amount of error in it, along with a truncated SVD and a TF-IDF. So a TF-IDF is a term frequency inverse density function. So somebody used new the most, right? So I had a choice, that if a number was used too many times, I can remove that out of my equation. So apparently new wasn't used that many times, but this algorithm, suppose say, what this algorithm did was, there were descriptions, as I show you, there were like 1,000 descriptions per category, people were writing that. So around, let's say, just for the convenience, there were 3 lakh different text or the words used by the people. So this TF-IDF removed, I'll say, half of the words for me. The most frequent words, because it understood that, these are all duplicates of people are just using that for, trying to
catch them out.
Yeah, exactly. So this removed the number of words, so I can have the quality words for my algorithm. And after using 150,000 words, So do you guys are getting what I'm trying to say?
Yeah.
No, somebody said no. No, we have it. You're getting it? So I had 150,000 words. So now if you study data science, what there is always the columns which represent what is the condition of an item and what is the does it provide free shipping. So all these, and I'll just make it easy for you guys. And let's say a brand. So if I say a brand is Apple, the condition is one, and there's also free shipping. So my algorithm was calculating that it can cost this much, $1,000, and there were many other features also in it. So this is what my algorithm is doing. It's just looking at the particular features and calculating its price. So this is basically what random forest is doing. And then we have a truncated SVD, which I will explain you why it is necessary. Just like these condition and shipping are there, these 150,000 words will have their own feature. They have their own columns. Just imagine 150,000 words. So brand, new, condition. So my algorithm will plot 101. Like if in description there was a brand, somebody wrote brand, there was one for it, new for it, and till 150,000 different words. So if I had 150,000 words on my local machine or my computer, my system would hang for sure. So what I could do is I could use something called a truncated SVD. So truncated SVD, what it does is it reduces the dimension of the these columns, and it can reduce that to 20 for what I did, because it was getting me a good answer. It was a hidden trial. So just by representing these 150,000 different into, now it was almost converted into something called like SVD1 to SVD20. These new dimensions in which it was represented. So in total I had around 30 features just like this, in which it was mapping 1010 and it was calculating the price. So this was my algorithm, and it was getting me 0.39% root mean square error. So if it's more closer to 0, the better it gets. It means you said the phone was $1,000 and I said 900 bucks. So I had an error of 100. So all these errors were added, but since it is something called a root mean square logarithmic error, what it's trying to do is it's just trying to decrease this 100 to around something 0 to 1, so it is easier to understand. So that was my whole project, and that was my testing data and my validation data. So any questions, like how could you do this, how could you do that? I'm open to that.
One question, like you said your key value was brand new condition, and based on these criteria your price is being evaluated.
Yes.
But then as you move from different countries to different countries, the terminologies differ. Like something, is this application targeting only a certain geographical location, or are you?
It's a Japanese brand. The Mercari is a Japanese Amazon.
Okay. So it's not valid in India?
No, it's not valid in India. For India, Amazon might have a different price selection technique, or OLS will have its own price selection technique which they are using it.
And like this price evaluation we get after this application, is it close to the ones which are in
Say, could you show me and the error once more?
So, as I got a
And
0.39, so the
0.6.
one second.
And what was the training error? You guys
No, we didn't calculate on the training. We just did on validation and testing.
Okay.
Training you means on the same training data we trained, right? Yeah, we didn't do that.
You didn't do that.
So yeah, as your question was, what was the question? Can you repeat?
How close does accuracy
To the real-time application which are used by the companies, right? So 0.39 isn't good because other companies, since it's a multi-billion dollar companies, they want to reduce it to, let's say, 0.001. Okay.
But like I'm just asking, this 0.39 is compared to what? Like how? What's the reference point to get to point P9.
Can you talk about this?
Yeah, this one. Sure, I'll talk about this.
I think that's what he's.
Yeah, I
inquiring.
understand that. So, like the example which I told you, if you have $1,000 phone and I predicted the price $900 for it, so I had $100 error, right? So, 100 error, this will be phi minus y dash. So, what I said was the original price was this, and I calculated 900. So overall was 100. This was my error, $100 error, right? For all the applications, I'll add this error. In the end, maybe let's say it comes around this value. So I can say this is my error. But now in my evaluation, in order to reduce the number and for more understanding, what I did was it's log y plus 1 minus log of y dash plus 1, and it's, yeah, 1 second. So yeah, this sigma represents all the items, and this is the same formula, but now this is inside log whole square to keep the number positive, and this is to average the whole term. So basically, I'm talking about that only, but in order it improves the understanding of a person.
Okay. And this 1,000 price range, like 1,000 is from where? Like how many should be 1,000?
So it's the
Just for
data.
understanding, like just
Yeah,
for
yeah.
understanding.
It's this data was calculated. It was given to us, so it was calculated by the company and the.
So the evaluation or the error methodology they had, that's the most common one on Kaggle. RMS LE is usually the one that they will use. The one that what he has up there, y minus y bar, that's called MSE, which is the most basic form of it. RMS is just taking the root of it and then the log of it. Yeah.
And just one small
Yeah,
question.
sure. Tell me.
It's like, do you guys have considered people lying? Like, what if someone just says brand new phone and it's
Exactly.
a new phone?
So that's why we had TF-IDF, right? As I told you. Term, okay, I'll just tell it. Term, can you go in algorithms? Sir? PPT algorithms. What? Okay, I'll just explain it right now. It was TF-IDF. Term frequency inverse distribution, inverse density function. So most people will try to tell that it's a new phone. So what it does is does that inverse density. So if the density or means the number of count for new is really high, it will remove that from the statement, or it will remove that word. It was reduced from 3 lakh to 150,000, right? So it removed those words which were occurring really common, or they were the count was really high.
So the idea kind of is that, like, if you use I use this example a lot. If you use the word significant, you use it rarely because only some things are significant. So it's kind of saying the words that are used rarely means that there's something significant going on, which is why they are of importance.
Any other question? How can I do that? What should I do about this?
Could you explain a little bit about that truncated
SVD?
Yeah.
So it's a concept which you will learn, if you are in data science, Jose will teach you. So basically, truncated SVD, as I told you, it reduces the dimension. So the function is similar to PCA. It's for a principal component analysis. But a truncated SVD, what's different is, I'll just explain you. So I said brand new name condition, okay?
Yeah.
But I also said there are 150,000. So a sentence will have at most 100 words, right?
Yeah.
What's remaining?
So like it'll have 100 words in remaining
49,900, right? 149,000 and 900 words will be remaining, right?
Yeah.
For every statement, let's say I was selling a mobile phone. This is an example. So it had brand new and condition, but the rest of the words was 0, 0, 0, 0, 149,900 zeros. So when I transfer this to a dimensionality reduction, the algorithm is confused. It's like there are too many zeros. What should I do? Because in PCA, what it tries to do is it tries to center it across 1 and 0. So 1 and 0 means if the answer is around okay, 1 and it centers around 0. This I can tell you, because otherwise I have to draw the diagram and show you. So that's why I use a truncated SVD rather than PCA. And what PCA does is, so these points were suppose these points were representing that these all items were present in it, or these all brand new or conditions were presented in it. So this is one graph. There will be another 150,000 graphs representing the same thing, right? The frequency. So what I did was I took all these points and I represented them on a principal component or a new axis rather than the conventional x and y.
Okay.
So I'm trying to reduce the number of x's to 20 x's.
Are those like predicted data points? Like for the
It's not predicted. It's like everything is like we're not predicting it. We are just trying to plot them on a new axis.
yeah. Oh, okay.
So maybe use that example of that two data types,
Two data
and then
types,
you
right.
shift them on the axis, then the distance closes them. So basically, it's like, I mean, there's an example where you have a class A which can be represented by circles and class B which is represented by x's, and they're on the same axis, right? And basically, the point is, can we find a representation of them which better? I mean, this is already like a good division of it. So if they're not clearly separable, right? Can I rotate the axis or find a different component along which to project them so that the separatability increases? Because that's what we want. To predict a class, I need to have them as separate as we can.
So as Udal said, like how do you separate a class? So I'm just giving an example. This is size, and this is the chance of having a tumor. So a tumor, okay, a cancer. Tumor is
A malignant tumor.
Oh yeah. So okay, this could be 0 and this could be 1. So
What's the size, sorry?
size, yeah, I'll talk about that. So this is 0 and this is 1. 1 means you have cancer. 0 means you don't have cancer or it's a benign. Malignant means it's an active cancer. So this is the size. So let's say it's in to the power of -5 meters. So it's really small. So I'm just doing it for the discussion sake. It's not the exact data. So let's say if the points were
It's the size of the tumor, is it?
yeah.
Oh.
So if you see, there is a demarcation in which after a point, if the size of the tumor increases, it becomes cancerous.
Yeah.
So there is a clear demarcation that if you draw a line like this or something like this, the algorithm will calculate this. You can easily calculate whether this will be a part of a cancerous tissue or not.
Okay.
Anything related to the project? What is this? What is that? I didn't understand. Anything which you can think of.
So the data you received from them was already categorized differently?
Yeah, it's already categorized. Because like as I showed you in the first part, when I was going through the website, people were already, they have a particular, what is the brand name, that is the brand name, what is the description. So they already do that, put that in there into SQL, and it comes into the form of a CSV, which is a format, comma separated values.
Were there any missing values, or was it like
Yeah, so
clean?
that's a good question. So a missing value is a person who is too reluctant. He's like, I don't want description, fuck it. So there was no description, And then what can I do about that? I still have to calculate the values of it. But when I put that inside my algorithm is like, bro, there's missing values. How am I supposed to do that? So regarding that, what I did was I just entered something called a missing value So I edited the data and I inserted missing values instead of it.
And when you were predicting price, were you basing it off of existing prices on the website?
Yeah,
You go out on the
exactly.
internet and
They-
look at the original prices or anything like that.
Maybe you can, if you have like the data frame.
Yeah, the data is not shared since it's
So just this. If you just show them this.
So this was the data provided by the website. Training ID. What is the name? Razer Black. If anyone knows, Razer is a company for laptops and phones. So, and if we go down, what was the condition of the Razer? 3 condition means it's okay, not good. Then it's part of which category? What is the brand? What are the prices? $52 for a Chroma keyboard and the item description. And if you see here, we have inserted missing when they were too lazy to write about it.
So now with that data, maybe I missed this in the initial. So how did you, and the price prediction was still based on how those match with other items and that's simple. There were no like weights for the categories or anything like that.
What?
You didn't have any set saying if this brand is this. No such data.
There was no like data saying that Nike is a very expensive brand, therefore give it a high weight. That is something that they need to identify themselves.
Right, just going back to
Because
the,
A Nike brand could be really expensive. It's a new shoe, or somebody used it for 5 years now. It's expected to sell, so you can sell for like $10 also, right?
so the basic idea was for every item that you were trying to predict a price for, you take all its attributes and go find something
A
similar,
model trying to.
and then yeah.
similarity is not something they're doing.
Okay, not similar, but you're okay. No, but I got it actually. But all that, but the world is still this website.
The word.
It's in the world for the data. It's still this
Yeah,
website.
there's no external data coming.
So the data was really huge. It was 1.4 million or 14 lakh entries just for training data and 9 lakh entries for the testing data. So 20 lakh data sets around total.
So yeah, I mean, for example, I think he's asking, they didn't collect any data outside this data set about Nike's average price. Nothing like that. It was all within the data.
We can actually do that. There's an option that you can have an external data set. Then you have to attend everyone. You have to post it online that you can use this data set. But that's.
No, I was just curious. So
No,
basically,
you can actually do that. You can go on their website and try to scrape the data. I think you'll learn scraping. So you can scrape the data. Scraping means going on a website and making a program.
because the reason I asked that question is, for example, that I approach a pricing problem personally when I'm on a website like this and I'm going to list it.
Yeah.
I'm not using the model that you're using. I'm not using other data to come up with it. I only know what it should be based on what I spent on it, what quality it is or whatever. Right? So I'm wondering if you don't take that approach at all. Right?
No,
That
you
would-
can create your own variables. Like let's say that if they had the date mentioned there, and if your intuition is that hey, I know that something that sells on Saturdays maybe is more expensive because people take the time to buy something more expensive on Saturdays. You can create that thing. He'll have the date. He'll create a new column where it'll say Saturday yes or no. Right? You can get external data as well, like you're saying. So you can create your own variables in
And
that.
there is no idea of like initial like cost price or anything like that.
See, there won't be an initial cost price because if you're trying to
List
sell.
price rather.
Sorry.
Because it's all second hand,
Yeah,
right?
it might not even be a useful feature to have.
Okay.
You might realize that because maybe it's the third hand.
Right.
And it's so far away from its listing price. So your assumptions may or may not be valid.
Anything else? Like she had some good questions, even if you had something. Anything you can think of. Whatever.
What was your inspiration for this project?
It was an online going competition, that's why I chose this. And it was using NLP, the natural language processing, which I thought, right now it's a really nice area to work on since it's not fully developed. As you can ask Siri some questions and it can't answer. So still like NLP is hugely complicated because a computer can't understand what a human being thinks or they're trying to convey through their speech. So I thought maybe I'll start with the data set and I'll learn something new about NLP. So,
Where did you test the data?
uh,
Locally or on DigitalOcean?
online.
There's no digital version.
And you wrote
Oh,
all
really?
this in Python.
Where do you test it?
It's like,
It's
what
data.
made you
Why do you need a
choose
server
this
to
like
test
website compared to
It's machine
all the
learning,
other
right?
websites?
So you need it to like
Amazon or
So
You need a
not
machine.
resisted the
like
competition.
update.
yeah.
It was an
So
online
why does
competition on
Oh,
Canvas.
Amazon.
so
Okay,
why
online
does
competition.
where does DigitalOcean come in? I'm too confused.
So like
because you need to leave it
audience,
running
you know,
so it can
like,
update
you were
the.
able to
Why can't it run on your
like,
local
any,
computer?
That was my question. Did you do it on the computer or was it so
actually
big
doing
that you
like,
had to do it?
Oh no. Even if it's so big, like you wouldn't do it on DigitalOcean. What you would do is you would use DigitalOcean to use DigitalOcean and then
You had
have
questions right
Hadoop
before.
over it.
Okay, cool.
Hadoop is HDFS.
I'm waiting for them.
You have
No?
break up the
Good.
data basically into more manageable
Okay.
pieces.
Cool.
Yes. Thank you. I don't think I have any questions.
Have you finished submitting already to the competition?
Yeah, I already did that. So right now I'm having 1800 ranking out of 2400 people. So in order to improve the ranking, I have to work on the deep learning part of it. Since the data is really huge, I can use the deep learning aspect of neural networks to incorporate on this. But then there are some things which I right now don't know that, like there's regularization parameters and stuff which I have to work on it. Plus, since the data in my predict takes time, so just running this notebook takes 1 hour. So that's the thing, I just need to learn more in order to.
So it takes 1 hour to run what?
Yeah, the data is really huge, right? So
But what exactly, like if you enter a test
It's
item,
like
it takes
since
1 hour
you-
to get an output or?
If it's 14 lakh rows, it might take an hour.
on your local PC, it might hang, so I'm using the online cloud for this.
I'd say the data sets that they used in class were usually not more than 10-15,000.
10,000.
So those in 2 minutes or 3 minutes might.
They might run on that, but in the end,
The people hosting the competition don't give you access, like some server space or something?
they do give 4 cores and 16 GB RAM, but sometimes even that's really less. So you have to ask for GPUs and also, So right now I'm using 64 GB RAM and 8 GB graphic card and stuff. So that's okay. Even that takes 3 minutes, so it's really frustrating.
It's competitive, so there's money involved. So if you want money, you might have to spend a bit of money on AWS. Or
But it's
something.
a fun process of learning, how you can use cloud processing. So since your computer, most of everyone's computer will have at least 4 cores, at most 4 cores. But on the server side, on cloud, they might give you 8 cores, 12 cores, 16 cores, as much as you can pay. So it's really fun and fast way to
Awesome. Any more questions for these guys? That was awesome. Saib, आपने थोड़ा कम बोला.
I was into data visualization. So we worked on algorithms.
Awesome. Thank you so much, guys. That was awesome.
Is energy a part of AI or something?
AI is a really huge branch. I wouldn't say